Okay, today we're going to continue our notes. We are in section 6.4, but we only have one more to go. That's problem number 10. So I've written the equations, there's A, B, and C up here. And these directions say convert to a polar equation. Now, this is incredibly easy. I don't remember if it was yesterday or the day before. I had you write a couple of things down in your notes. Told you to circle them, highlight them, or whatever. And one was x equals r cosine theta, and y equals r sine theta. Those are called your conversion equations, and they are incredibly important. So hopefully you wrote them down and highlighted them when I told you before, but you might write them down and highlight them here too. X equals r cosine theta, y equals r sine theta. Now, the reason that I said these problems are so incredibly easy is because all you need to do is take those things and substitute them in for your x and y. So here's what I mean. Well, first of all, this is what we call a rectangular equation. This is rectangular because the variables are x and y. Remember, rectangular has x and y as your variables. Polar has r and theta as your variables. So when these directions say convert to polar, what they mean is get rid of the x's and y's because this is rectangular, not polar. So all we're going to do is take this x and replace it with r cosine theta plus 2 r sine theta equals 3. And that is all there is to it, you guys. That's it. Now, if we were going to be sketching this, which we are not, we might want to manipulate that equation a little bit, change its form, move things around. But that isn't our objective. Right now, your sole goal is to take a rectangular equation and replace it with the equivalent polar equation. And to do that, we simply take out the x and replace it with r cosine theta, take out the y, replace it with r sine theta, and that's it. That's the end of the story. Okay, same thing here. This is exactly the same situation. So we're going to have 2 r cosine theta minus r sine theta equals 7. So we take out the x and replace it with r cosine, take out the y and replace it with r sine equals 7. Done. And this one, exactly the same thing. R cosine theta equals 9. And that's it. So, number 10 is done. That's all there is to it. Make sure those are highlighted in your notes. Okay. Now we're moving on to 6.6. In our notes. And we are going to plot a complex number. So this is 6.6, and this is number 1A. And we are going to plot the number 1 minus 2i. Now, this is called a complex number. You've seen those before. And now we're going to graph it, and it's very, very simple. We're going to graph it on a regular Cartesian framework. And we're just going to count over 1 and down 2. So we're going to plot the point 1, negative 2, and make a little vector that comes out like that. So that's it. That's all there is to it. Please don't let the eye confuse you. This is what we call the real axis. This is the imaginary axis. So we plot the real number over 1 and then down 2. So that's all there is to it. And then draw a little vector in there. Done. So B says a negative 2 plus 3i. So negative 2 plus 3i. So I'm going to plot the point, negative 2, 3, negative 2, 3, and start at the origin, make a vector. There it is. There's the point, negative 2 plus 3i. Wow, you're thinking today's lesson is super easy. Well, it is. It is. Okay, C. C is just the number 4i. Now, don't be confused by that. Another way of writing that would be 0 plus 4i. Isn't that the same thing? So if it helps you to think of it that way, go ahead and think of it as 0 plus 4i. And then when we graph it, we're over 0 and up 4. So we're straight up 4 units. And I think, can you see my vector there? That's your vector. Just straight up 4 units. Because it's 0, 4. So 0, 4 would be right there. Okay, that's easy. All right, now we're moving on to section 2, or number 2, which says, write the number in trigonometric or polar form. It always gets so confusing because there's so many ways to express an idea. But trigonometric form, okay, this is rectangular form. Rectangular form is also sometimes called complex form or Cartesian form. So why don't you just make a little note that all of these mean exactly the same thing, and they mean the number looks like that. That's rectangular, complex, or Cartesian. All those words mean that. Now we're going to change it into polar form, which is also called trigonometric form. So again, you might see, the directions might say change to polar form, directions might say change to trigonometric form. The answer is the same thing. They are the same thing. All 3 of these mean the same thing, and both of those mean the same thing. And that is RCIS theta. That is called polar or trigonometric form. Now, I'm going to tell you what that CIS stands for in a minute. But first, let's go ahead and get the question answered, and then I can erase some of this other stuff, and we can dig a little deeper into what that means. That's CIS. Okay? Now, remember a minute ago when we were graphing this, we treated this like the X and this like the Y. Remember when we plotted, we went over 3 and up 4. So this is the X and the Y. I need to find the R and the theta that goes with that X and Y. We already have practiced that in an earlier section. Not today, but a couple days ago we practiced that. So I'm going to graph. I'm going to go over 3 and up 4. I'm going to graph that and make my little butterfly bow tie. Over 3, up 4. This, guys, is R. Remember? R is like the magnitude. It's the hypotenuse. So I'm going to find R by squaring the first one, squaring the second one, adding them up and taking the square root. So R is 5. R is 5. This is theta. And if you recall, we found theta by recognizing that the tangent of theta, the tangent of that angle, is 4 over 3. And then we second tangented 4 over 3. So that angle, second tangent, 4 divided by 3, is 53.13. So when I write my answer, my R was 5. CIS, we're going to talk about what that means, 53.13 degrees. And this is the answer to the question. Now, I don't know how well you've been keeping up and following all of your notes, but that skill, finding R and finding theta, is exactly what we did back in 6.4, number 2. That is exactly what we did. Okay. Now, I want to talk about this notation for just a minute, and then we'll do the, there's a couple more examples. We'll go ahead and do those too. But let's talk about what that means first. This answer can actually be written a different way. Okay? So I'm using what's called the shorthand notation, but the longhand form of that would be 5 parentheses cosine 53.13 plus I sine 53.13. So this is the long version of that answer. Now notice you got your 5 out in front, and then you have cosine I sine, cosine I sine 53.13. So we have the cosine 53.13, and then I sine 53.13. And notice that the I goes with the sine because the sine is y, and in the original number, the I was on the y number. Remember, this was over 3 up 4. This was x and y. So that's why the I goes with the sine. So you are welcome at any time to write your answers like this, using the shorthand, cosine I sine shorthand, or to write it out officially like this. I think you can see why I like the shorthand better. All right, let's try another one. Next, we have -2 plus 2i. And we're going to change that into RCIS theta, which means we have to find R and we have to find theta. And we're going to do that the same way we did it a couple days ago, the way we just did it a minute ago. We're going to draw a picture of this number. So we're going to go left 2 and up 2. Make our right triangle, butterfly bow tie. This is a 2, and this is a 2. Now we're going to find R. This is R. Right here, this is R. We're going to find R by squaring the first one, squaring the second one, adding them up, and taking the square root. So that's the square root of 8, which we know reduces to 2 root 2. Square root of 8 is 2 root 2. So my R is 2 root 2. Now I have my CIS. Now I need to find my theta. Now this one is a little trickier than last time because this is theta. This right here is theta. But we can't figure out what that is just yet. You'll have to figure out what this is. I'm going to call it A for angle. And I know that the tangent of that angle is 2 over 2. Opposite over adjacent. So A is going to be second tangent 2 over 2, which is the same as 1. So some of you probably don't even need to type that one in on your calculator, although you certainly can. This is a 45-degree angle. When these two numbers match, that's a 45. But your calculator will tell you that. Go ahead and type it in. So A is 45. What is my theta then? What is my purple angle? Well, my purple angle, if we went all the way around to here, it would be 180. But we stopped before we got there. We stopped 45 degrees before we got there. So theta is 135 degrees. 180 minus 45. And again, you can write your answer with the shorthand, or you can write it out longhand, which would be 2 root 2 cosine 135 plus I sine 135. I don't care which way you write it. This is fine, and this is fine. This is the shorthand. This is the long version. Both are polar form. This is called polar form or trigonometric form. This is called complex form, original problem complex, Cartesian, or rectangular. We're changing from complex, Cartesian, rectangular into polar or trigonometric. Okay, next page, got another example there. So this one says 4 root 3 minus 4i. And we're going to change that. All right, so we got to find our r, and we have to find our theta. So we're going to draw a picture of this. So we're going to come over 4 root 3 and down 4. So we come over 4 root 3 and down 4. And we're going to find our r. Now, this is going to be a little tricky. I want you to be very, very careful when you do this. We know that to find our r, we have to square the first one, square the second one, add them together and take the square root, right? Now, when you square that first one, you see how I have parentheses there? That is necessary. So if you're going to square this on your calculator, some of you can square it in your head probably, but if you square this in your calculator, you've got to have that in parentheses. So we're going to have parentheses 4 root 3, and then we square that, and we get 48. So if you're not getting 48, you need to do it again. And if you're still having trouble, then take 4 root 3 times 4 root 3. It should work out fine if you put in these parentheses. So I got the square root of 48 plus 16, which is 64, and the square root of 64 is 8. So my r turns out to be 8. So r is 8. Now, this is my theta. But of course, I'm not going to find it first. I'm going to find this first, right here. Now, what do I know about that angle? I know that its tangent is 4 over 4 root 3. So its tangent, this is going to make it easier for me if I reduce it, is 1 over root 3. The 4's cancel. So tangent is opposite over adjacent. So 4 over 4 root 3. I'm going to go ahead this time and cancel those to give me a simpler fraction. And then I will second tangent 1 over root 3 on my calculator. So second tangent 1 divided by the square root of 3. And that angle A turns out to be 30. Do not put 30 here though. That wouldn't be right. The purple angle goes here. So if that is 30, what would all this big purple angle be? Well, if you said 330, you are right. Because it's 360 minus 30. And there's the answer to the question. Now, I do want to make a note here before we go any farther. It really doesn't matter over here when I reduce this fraction. It really doesn't matter if you reduce it or not, but I want to just caution you, if you're not going to reduce it and you're going to second tangent 4 over 4 root 3, that 4 root 3 has to be in parentheses just like it was when we found R. So if you're going to type it in without reducing, you must put that 4 root 3 in parentheses. Anytime you have a double number like that, 4 root 3, 2 root 6, whatever, you got to put it in parentheses when you're entering it into your calculator. So that's why it was easier over here just to cancel it out and not have to worry about that. But this will work. If you type this in with the parentheses, you will get 30. Okay, we have one more in this section. Notice I'm writing it 0 plus 6i because that helps me draw a picture of it. I'm going to change that into polar form. So I need my r and my theta. And believe it or not, this one isn't even going to require the use of a calculator at all. If you graph 0 plus 6i, it looks just like this, straight up. How long is that vector that I just drew? What's the length of that vector? What's the magnitude of that vector? It's just 6. It's 6 units long. You counted up 6. There's no Pythagorean theorem. Actually, there could be. You could square the first one, square the second one, add them together and take the square root. But you get 6. And then your angle is right here. And that one, since that's straight up the y-axis, you know that is 90. So that one was easy. Okay. The next section is the opposite of this. And it is the easier of the two sections. So it is easier now. We're going to take a number. I'm doing, this is 3a. And the number is written out in long form. But remember, that means the same as this. So you're not going to be confused if you see it in short form. This is 3a. The problem can be written in long form or short form, doesn't make any difference. Now this is the polar, and we're going to change it to rectangular. So we're going to change it so it looks like the numbers in our last section. Now remember, this is your r, and this is your theta. A couple days ago, and again today, I had you make sure that you have in your notes x equals r cosine theta, y equals r sine theta. So your job is to find x and y. We know that r is 5 and theta is 20. So x is simply 5 cosine 20, and y is 5 sine 20. And it is that easy, you guys. 5 cosine 20. So I have to do some rounding. So 4.70 and 5 sine 20, 1.71. Done. That is the answer to problem A. That's all there is to it. Right here. Wow, that's easy. And guess what? It does not get any harder. They're all that simple. I shouldn't have erased this. Make sure this is in your notes. This is the key right here. All right, so B is 8 CIS 12. So here's your R, here's your theta. So X is 8 cosine 12, and Y is 8 sine 12. So the answer to the question is going to be X plus YI. That's what complex form means. This is complex right here, or Cartesian or rectangular. All those words mean the same thing. So 8 cosine 12, 7.83, plus 8 sine 12, 1.66. And remember, the I always goes with the Y. All right. Oh, now we got one. It's a little bit of a curveball here, but not for us. We got it. That's a radian measure. Now, you can certainly do the problem in radians. You'll have to change your calculator to radian mode. I have absolutely no problem with that. My concern is that sometimes when we change it to radian mode, we forget to change it back, and then we have all kinds of trouble. So I think I'll go ahead and just change that into degrees. I know how to do that. I know pi is 180. 180 divided by 10 is 18, and 3 times 18 is 54. So this is 4 CIS 54. So one more time, 180, pi is 180, divided by 10 is 18, times 3 is 54. And if you can't do that in your head, that's fine. You have a calculator. Just figure it out. All right, so now we need our x and our y, and here's how we're going to find them. X is 4 cosine 54, and y is 4 sine 54. R theta. So, 4 cosine 54, 4 sine 54. So 2.35 and 3.24. Don't forget the I with the Y number. So this is what I typed into my calculator because these are my formulas that I'm going to always have with me highlighted. R is 4, theta is 54. Type it in. Okay, and then we got the last one in this section, which is written out longhand. Do not be alarmed. That's the longhand. It means the same thing as 6 CIS 200. Means the same thing. This is your R, this is your theta. So x equals 6 cosine 200. And y equals 6 sine 200. So 6 cosine 200, 6 sine 200. So we got negative 5.64. Don't be alarmed. X and Y can certainly be negative. You know that. And minus 2.05. All right. That takes care of that section. All right, now we're on to number 4. Number 4 says we're going to multiply. Now, I don't want you to be confused by the notation. I'm using the notation used in the textbook. Make sure I copied that right. Yep. So Z1, Z sub 1, and Z sub 2 are simply the names that we have given these numbers so that we can refer to them without having to write out the whole number. So this is Z sub 1 and this is Z sub 2. And we're going to multiply those two numbers. Now I'm not going to go through the long, drawn out proof of this. It's really cool how it all works out. But what we're going to, oh, excuse me, it involves a bunch of foiling and stuff. We're not going to do that. I'm just going to tell you that in order to multiply these two numbers, it is very, very simple. The product of these two numbers is 30 CIS 23. Now, can you figure out how I got from the problem, which is these two numbers, to the answer, which is their product? I multiplied these two numbers together. Notice that's a 30. 30 came from multiplying the two r's. So whatever the r's are, remember this is r and this is theta. So whatever the r's are, you multiply them. And then this came from adding the thetas. So the r's are multiplied and the angles are added. And that's all there is to it. That's the answer. So I multiply the r's and I add the angles. Now look at the next one. Trying to make sure I'm doing the right problems here. 4 CIS, yep, okay. So we're going to multiply them. So the rule is, and you need to write down the rule, make sure you have good notes. We multiply the r's, so that's 20. Multiply the r's, that's 20. And we add the angles. So that would be 410. So I multiply the r's, and then I add the angles. Now, this one has a little bit of a curveball thrown in here. What can you tell me about 410 degrees? Yeah, it's more than once around. It's more than a revolution. So we don't like that. We don't like to have angles that are more than a revolution. It's wasteful. You just spin around. So we're going to revise our answer. And we're going to write it as 20 CIS 50. Now, how did I get from 410 to 50? What did I do? I took out the extra revolution. This is more than once around. 360 is once around. So any number bigger than 360 is more than a revolution. So we don't like that extra revolution, so we take it out. 410 minus 360. Shrink the angle down so that you have what the angle actually is and not all that extra spinning around. So this is the answer to the question. If your angle turns out bigger than 360, subtract 360 to make it a normal angle. Okay. Now, the next section deals with division. It says find the quotient. Okay? So we're going to divide these two numbers now. Now, I want you to look back up at your notes for problem 4. This is problem 5. For problem 4, when we were finding the product, we multiplied these and we added these. That's how we did the multiplication. We multiplied the r's and we added the angles. Now take a wild guess what we're going to do in the division problem. We're going to divide the r's, so we're going to get 2, 10 divided by 5, and we're going to subtract the angles. So when you do a division problem with complex numbers in trigonometric form, polar form, you divide the r's, so 10 divided by 5, and subtract the angles, 20 minus 11. So when we multiply the r's, add the angles. When we divide the r's, subtract the angles. So that's the answer. All right, so the next one's 18 CIS 200 and 15 CIS 300. All right, so we're going to divide. Now, when we divide, we get 18 over 15. We're going to reduce that, so that'll be 6/5. And it's okay, r can be a fraction. Or if you want to make that a decimal, you certainly could make a decimal. If you did 18 divided by 15, you get 1.2. So if you like that better, you can certainly use it as 1.2. And then we're going to subtract our angles. Now, it's always top one minus bottom one, so it's going to be negative 100 degrees. So we divided the r's and got either 6/5 or 1.2 and subtracted the angles and got negative 100 degrees. Now, here's another curveball. Remember a minute ago when we got that big angle? I think it was 410 degrees. And we said, nope, can't have it because it's too big. So we subtracted 360 from it to make it the right size. This is the same kind of problem. We don't want a negative angle. So up here, we subtracted 360 to make it a nice normal angle. Here we're going to add 360. So we're going to add 360 to that angle and get 260 degrees. If your angle turns out either too big or too small, this is too small, a negative, too small, we're going to either add or subtract 360 to fix it, depending on what the situation is. So here we subtracted 360 to get 50. That was in problem A, or 4B. That was 4B. And now in 5B, we've got an angle that's too small, so we're going to add 360 and get this as our final answer. And again, this doesn't have to be a decimal. It could be 6/5. Okay. So now we're on to part 6, and problem A is 2 plus 2i to the 4th. Okay. Now, you could all do this problem by foiling. 2 plus 2i times 2 plus 2i times 2 plus 2i. But that would take 4 ever. So what we're going to do is we're going to change it into polar form, also called trigonometric form. So that's going to be our first step. Now, that means we're going to change into this form. Now, I know there's not much room down there, but you're going to have to try to squeeze all this information in because it's important that you take notes. There is some space on your next page that maybe you want to carry over to there, but we want to have really good notes on this section. So the first thing we're going to do is change this number into polar form. So keep in mind, this is x and y. So I'm going to draw, I'm going to go over 2 and up 2. X is 2, y is 2, over 2, up 2. Here's my r. So I'm going to square the first one, square the second one, add them together and take the square root. So my r is 2 root 2. And then I'm going to find my theta, which is that angle actually. It's in the first quadrant, so it is the angle. So the tangent of the angle is 2 over 2. So I'm going to do second tangent 1. 2 over 2, that's 1. And again, some of you probably don't even need a calculator for this. That's 45 degrees. When these two match, it's always 45. So here is the number in polar form. So step 1 is do what we did back in an earlier section. What was that, section 2? Yes. Back in section 2 today, one of the first things we did today was we changed that number into polar form. So now here it is, right here. But we still need to raise it to the 4th power. Okay? So now I have that number, step 1, change it into polar form. Okay. Now I'm going to the next step of the problem. I have this now. I've changed it into polar form. And now I'm going to do step 2, which is to apply de Moivre's theorem. Okay? Now, it works very, very simple. We're going to raise r, this is r, and this is theta. We're going to raise r to the power, so I'll make a little note here. Raise r to the power and multiply theta times the power. That's how de Moivre works. Okay, very simply, that's how it works. This is your r, this is your theta. So we are going to raise r to the power and multiply theta times the power. So we're going to take 2 root 2 to the 4th. So we're going to raise r to the power, and notice my parentheses, talked about this earlier. If you have a 2-part number, you've got to put it in parentheses before you put it in your calculator. So 2 root 2 to the power, and then we're going to take 2 root 2, and then we're going to take the angle, 45, times the power. Okay, so on my calculator, I'm going to do parentheses, 2 root 2, and I'm going to square that. You should get, oh no, I don't square that, I raise that to the 4th, I'm sorry. So here, let me try it again. 2 root 2, and I'm raising that to the 4th power. So I get 64. And then I take 45 times 4, so I get 180. And that is the trigonometric form of the answer, or the polar form of the answer. Now these directions are wild and wacky because they say answer in both complex form and polar form. So this is the polar form answer. So now I'm going to take that answer, I've got to erase all this stuff again. I'm going to take that answer and I'm going to change it into polar, or no, into a rectangular form or complex form. Okay, so this is the polar form right here. This is the polar form. Now, I need to change that into the rectangular form, or the complex form. This is complex, rectangular, Cartesian, whatever words you want to use. We're changing it into that form, which means I have to find x and I have to find y. Now, I keep writing it down, but x equals r cosine theta and y equals r sine theta. So to make the switch from polar to rectangular is going to be super easy. We're going to take 64, that's r, cosine 180, remember this is r, this is theta, and 64 sine 180. So 64 cosine 180, whoa, 64 cosine 180, and 64 sine 180. So this gave me negative 64, this gave me 0, so my answer is negative 64 plus 0i, or if you just want to write negative 64, that's okay too, because 0, 0. So the two answers to the problem are this one, this is your polar form, or your trigonometric form, and one of these here, either this one or this one, it doesn't matter. That is your complex form. That is a lot. So we're going to stop there for now. And there are 3 more of those. We'll work on those next time. Have a good day.